Hello guys, welcome to my YouTube channel. So today we'll be solving Codeforces contest 906 problem G. Okay, so pause the video, read the question, then I'll explain the question. Cool. So let's go to the drawing section now. So in the question, what we have is we will have different cities with their population like A1, A2, etc. Something like that, right? Now, initially they are all disconnected, and we have to connect them such that in the end, they all becomes one single component. So they were disconnected, disconnected, or I will say n cities we had, and we have to finally connect all the cities and make one connected component. Now, to make this what the condition we have, let's say there is one connected group of cities. So this, let's say we have connected group of cities, and this is another connected group of cities, right? So let's say this is something like this, and we want to connect them. Let me change the pin, and we want to connect these one with these two city. Let's say this is city I, and then this is city J. So then what should be the condition? That summation of a k will belong over set S should be greater than I into J into C. I know this would be a bit ridiculous, but let's break down what the question is exactly saying. So what this left hand part means, that it represents the sum of all the cities population. So we'll be given the population for all the cities. So it will be the sum of population of all the cities, that is either in connected component I or either in connected component J. So like if, let's say, if there were few more cities here and there, so then we don't need to care about them. But all the cities that is connected with I, including this ith city as well, and similarly all the cities connected with J should all be taken into account. So like if this is A1, A2, then it will be like A1 plus A2 plus this AI, and then AJ, and whatever this population. Okay, that should be greater than I into J. The I and J are the city number. So this was city number I and city number J. So if we will just consider two cities, X and Y, and if we want to make a edge between them, then in this scenario, this equation will be simply reduced to AX plus AY should be greater than X into Y into C. I forgot about C. This is nothing but a given constant. Given constant. Okay, it was a given constant in the question. Okay, so this is the basic basic expression we need to take care of. Now let's say if we have connected few more cities with this x1, like, okay, so and initially let's say it has population of 3, it has population of 10, it was population of having 5, it was population having 7, and it was also connected to population of, let's say, 10. So like when we are in and for the time being, let's say this bond was not there. Okay, and now we want to make this bond. So ideally we are connecting this x city with this y city. So ax plus ay should be greater than equal to x into y into c. But this x was already connected to this one, right? This and this city. So ax will be not just 5, but it will be the sum of 5 plus 3 plus this 10, and similarly ay will be this 7 plus whatever the connected component this is connected with, or the cities it is connected with. So it will be like 5 plus 3 plus 10 for this x. Similarly 7 plus 10. Why? Because this is the connected component, this is another connected component, and here x will be the number of this city and y will be the number of this city, and c is some constant given it. Now, so like it seems very difficult problem that how we'll land up. Yeah, and one more thing, we just need to tell yes and no. Okay, it doesn't matter, like we don't need to give any order or something like that. We just have to tell whether it's possible to make it all into one connected component or not. Now it might seem like it's a very difficult problem, but no, it's not. The only solution you need, or the only thing you need right now, some basic maths. So if we'll see this expression x into y into c. Now ideally we can choose any city. So let's say if we are choosing city 2 and 3, okay, 2 and 3, then this expression will become a2 plus a3 multiplied by 2 into 3 into some c. If we are choosing, let's say, city 3 and 4, then it will become a3 plus a4 should be, it is 4 not y, should be greater than 3 into 4 into c. If we are choosing city 1 and city 4, it will become a1 plus a4 should be greater than equal to 1 into 4 into c. Wait a second, what did we see just right now? What did we see? We saw that if we're taking city 3 and 4, the expression was something like a3 plus a4 and 3 times this 4 into c. Similarly, if we're taking 1, then it was a1 plus a4 and 1 into 4 into c. It was, this side was 3 times, this is 1 time. Why we are talking about this RHS? Let's say this is RHS and this is LHS. So why are we focusing on this one? So now see, we are seeing over here is this should be like LHS should be greater than RHS. What we are seeing that LHS should be greater than RHS. Now to fulfill this, we have two solutions. Either we can keep on increasing LHS or keep on decreasing RHS, or we can do both. That like we can increase RHS and similarly decrease we can increase LHS and similarly decrease RHS. Now let's say we have taken one city with maximum population. Let's say city Y has maximum population. Okay, so this is the maximum population or maximum people. Now then the equation will become something like this. I mean, it will remain same, x into y into c. The only thing we know is this ay is maximum. Now from here we have two possibilities. Either a of x will be less than a of y, or a of y, sorry, a of x will be equal to a of y, because we already know that a of y is maximum, right? So let's talk about this second case first. If a of x is equal to ay, then what we can write is a of y multiplied by, sorry, plus a of y should be greater than x into y into c. Remember, ax and ay were equal, not x and y, so it will be x into y. So what we can write down is 2ay should be greater than x into y into c. Okay, now let's say if we putting x is equals to some random value, or it's better start from 1. If x will be 1, what we can write down it, 2ay should be greater than equal to yc, or from here what we can say is ay should be greater than equal to just 0.5 yc by 2, or 0.5 yc. If we'll put x is equal to 2, then what will happen, it will become 2ay should be greater than equal to, here x will become 2, right? So it will be greater than 2y into c, and here we can simply cut this 2 and we can write ay should be greater than yc. If we'll choose x is equals to 3, then it will become 2ay should be greater than 3yc, and here we can conclude that ay should be greater than 1.5 yc. So what we can see over here is that as we are increasing x, we can see that see, we know that the value of yc will be fixed, right? Because c is a constant and this y is the city number of yth city. So this will be the constant, right? And this is also constant. So what we can see, and yeah, we have one assumption that ay is maximum right now. Okay, ay, we are taking ay as maximum. Okay, anyway, it won't matter, but let's say for the time being ay is maximum. So if ay was maximum, then we realize that ay should be greater than 0.5 yc if we are taking x is equals to 1. If we are taking x equal to 1, then it's only 0.5 yc. And as we are increasing x, so let's say if y into c equals to 10, then 0.5 yc will be equals to 5, right? So from here, for like taking all these three, what we can write is, for the first condition, it will become ay should be greater than equal to 5, right? Then for the second condition, it will become ay should be greater than 10, and the third condition, ay should be greater than equal to 15. So from here, what we realize or what we can say is that if if let's say for any value, this condition holds true, this condition holds true, that is ay is greater than 15, that means ay will be greater than 10 and ay will be greater than 5 as well. So we know that if for any greater x, if any greater x, this ay is satisfying the condition, that means it will satisfy for 1, right? Either, and if it is not satisfying for 1, then it's not going to satisfy for any other numbers or any other city. So what we can realize, or what we can say from here is, it's always better to put x is equals to 1. It's always better to put x is equals to 1, right? Now, or x equals to 1, or the city 1 along with any other city y. So, and here we had another case, right, that if ax was less than y, so in this scenario we'll also know that this LHS will be decreased slightly more. So at the end we'll have similar conditions, just that the ay value will be little less. So in that scenario as well, this the ay, whatever the ax value we have, or something lesser value, so let's say 0.7 ay, because whatever we will have, like let's say something, so in this scenario let's say ay is not, ax is nothing but 0.7 ax, sorry 0.7 ay. So in that scenario all the question, or all the solution would become something like this one, right? That 1.7 ay should be greater than x into y into c, and if we'll keep on increasing, we will see that for x is equal to 1, it will be something like y divided by 1.7, and if x is equals to 2, then y should be greater than twice of yc divided by 1.7. So we still realize that picking 1 was our best choice, because if ay is greater than twice of this one, then it will definitely be greater than simply yc by 1.7. So what we realize here is, if we will take 1 with any a of y, then it will be our best scenario. Okay, because it will simply will have to will have to satisfy this equation. Now what we what we assumed was ay was maximum, ay was maximum. Okay, so like let's say even ay was not maximum, ay was not maximum, then also we saw that for any city, or any city y, we know that this condition will still be true. Like if we will put the one a of 1 with any city, this condition will still be true even if this ay was, ax was not equal to ay. I put that because just to simplify the solution. But if ay is not maximum, then also we'll have similar kind of approach, right? But in that scenario it will become little less, it will become more complex to visualize, that if ax is greater than a of y, if x greater than a of y, then you will say something like this, that it might happen that if I will put y into c over here, then it might happen that like taking x is equal to 2 over here, then it might happen that it satisfy the condition. Maybe that can be the case, but let's say if I here is if and but, like it may satisfy or may not satisfy. But if we start from maximum ay, if we start from maximum ay, then we know that it's always best to pick one. It's always best to pick one. That's one observation for maximum ay. So what we'll do, we'll pick maximum one, we'll combine with one, then we'll pick whatever the rest we have, the maximum ay, or and we'll combine with it 1. Now we are just if you'll see the equation, now what we have something like this: ay should be greater than yc, or we can simply write that ay should be greater than yc minus a of y, yc minus a of y. Now if we'll simply see, keep this value. So if we'll calculate, we have all the cities, right? Something like a1 comma 1, this is the population of one city, and this is the number of first city, or the city number, we can say. Similarly a2 comma 2 and a3 comma 3. So we know that we can go something like up to n. We know that we are already taking out one city, right? So let's say initially we have x is equal to the population of one city. Okay, now for the remaining cities, what we can do is we can sort them. And how we'll sort them? So let's say if I have two cities, if I want to merge two cities, that is AY, so it will be something like this, and I want to merge city Z with ZC. So in this scenario, we'll have to decide which city to merge first. So if let's say this both are satisfying the condition, what condition? We can we can simply write that this condition can be evolved to something like this, that A1 should be greater than equal to YC minus A of Y, and this condition can be written as A1 should be greater than ZC minus ZA of Z. If both are satisfying the condition, then it doesn't matter. Then it doesn't matter, because if we'll combine with A1 with, or the city 1 with city Y first, let's say there are three cities, right? So if I'll combine with one city with city 1, then this will become combined, and the overall population will become A1 plus A of Y. And we already know that A1 was greater than ZC minus A of Z. That means if we will increase A1 by A of Y, then also this will condition be true, and we can join this one. But let's say if this was not the case, if this does, and also, or the second scenario, both were satisfying, right? So we joined it for Y first and then joined it Z. Even if we will choose Z first, then also this condition was true, and we could have joined Y. But let's say if Y was satisfying and Z was not satisfying, so it might happen that this first condition was satisfying right now. So what we are saying, that this condition is satisfying, but this condition is not satisfying. So it might happen that when we will do this condition first, or we will just apply this condition first and merge 1th city with yth city, then this A1 will become A1 plus AY, and the second part will be same, because we will be joining them with first only. Okay, so the second part will be ZC minus A of Z. So initially it was just A1, now it become A1 plus AY. So it might happen that it may satisfy, but if it does not, still does not satisfy, then we can't have one single component, and we can simply print no and can return from the solution. Okay, what I'm saying is, if it is not satisfying, the condition, then we can simply print no, because what will that happen is that there will be a bunch of components which is connected with A, or one city 1, and there is this city Z. We know that if we can't merge it with city 1, then we won't be able to merge it with any other city, because we have already evaluated those situations, right? That if we'll keep on increasing the city number, the chances of that city to satisfy this condition get thinner and thinner. Okay, so in that scenario, if we are not able to combine with one, that means we won't be combining it to any other, and we won't be able to form one single component, right? So we can simply return no. Else if it's satisfying, then we can simply increase the population by whatever the population we have in the city Z. I hope the solution would be clear to you. Let's move to the solution. Let's move to the code, sorry. Ah, so we have taken the input. We have first, see, I have just stored the what do we say, population of city 1 in X, and then we have run a loop for I equals to 1 till I less than n. That will effectively run just n minus 1 time loop. We have taken the input of population, then we have assigned the city number, that is the, see, we already have city 1 input here, so we are starting from city 2, so just assigning city 1 city number as I plus 1. Then we are sorting on the basis of the same thing, whatever the this value was there, so whichever the lesser value we have, because we know that a1 a1 should always be less than, or what, a1 should always be greater than whatever the city yc minus a of y. So lesser the value it have, the more the chances to satisfy the condition. So we are sorting in the same fashion, that whichever the lower value, we will put that first, or we'll put that first. Now after sorting, we are just running a loop. We are checking whatever the y value, that is just to check the condition, and if that's a check, not y is not the city number, basically y is representing this whole expression value, so that we can see over here. And if that is less than x was nothing but the total population connected with city 1, then we can simply see out no. Else we can increase the population of city 1 by whatever the population we have in this kth city. Okay, And if we complete the loop, that means we are able to make one connected component and we can finally print yes. Okay, this was some AC solution. You can see over here. I'll give the solution link in the description. But if you guys have any doubt in this question, do let me know in the comment section. Okay, thank you guys. See you in the next video.